We are applying actually torque equations. This is some hinge fixed, and you have a thread like arrangement here that holds this in equilibrium, this plate in equilibrium. The plate is of mass m, dimension a. It's a square plate. Square plate. Remember, I am just cutting the string at this point. At that instant, what I want is immediately after cutting, string at B. This is B and this is A. Determine acceleration of center of mass, angular acceleration, reaction of hinge. This is what we want. Reaction of the hinge. Simple. I told you very clearly, if it is a fixed axis, always apply torque equation about that axis. Always apply torque about that axis. Any doubts? If it is a free axis, apply about center of mass. Or movable. Free axis means, like for example, here, throughout the motion of the square plate, A is always fixed. But sometimes A will also move, depending upon the case. In that case, apply torque equation about center of mass of the plate. Right. Now, I'm applying torque equation. I've identified that now I'm assuming that this is the weight force, right? About this point, acceleration of center of mass is ACM. And I am assuming that, try to please understand that this is ACM Y, this particular center, and this is ACM X. About the hinge, let us assume that the reaction Rx, reaction Ry. You should ask me one question. How do you know that ACM exists? ACMX exists. Remember, with respect to this is the direction of R alpha. When R alpha is having this direction, for example, perpendicular to this, it will have two components. One component along X, the other component along Y. So therefore, you are expected to have Rx as well as Ry. This is the first observation. If you fail in understanding this question, you will fail in decoding this diagram. Now mg minus ry is m acmy, equation 1. Similarly, rx is equal to m acmx, equation 2. Now you need to apply torque about this point, torque about A. Now torque about A is mg time, this is the line of action of the force. And this is the force arm. Yes or no? How to apply torque equation? Line of action of the force into the perpendicular distance, A by 2. So mg A by 2. This is I alpha. Anika, I about what point I need to take? I about what point? About A. mg A by 2 is equal to MA square. This is MA square by 3. This is MA square by 3. So what is this? 2 by 3 MA square alpha. Cancel A. Cancel M. So alpha is 3G by 4A. Right. So you got alpha. Right. Remember ACM is R alpha. What is R here? R is nothing but A by root 2. So A by root 2 alpha. So now I can give you everything. Why? Because what is, no, where this is ACM and this is 45 degrees. So therefore ACM X is ACM by root 2. Basically that is A alpha by 2. Similarly, ACMY is equal to ACM by root 2. That is again A alpha by 2. I got ACMX, ACMY. Right. Now what will happen here is Rx is equal to MACMX, which is nothing but ACMX means A alpha by 2. What is A alpha by 2? 3G by 4. Actually, A alpha is 3G by 4. So 3mg by 8. What is Ry? Ry is mg minus MACMY. Practically ACMX is same as ACMY. So this is mg minus 3mg by 8. And this will become 8 minus 3, 5 mg by 8. That's all. So you have Rx, you have Ry, root Rx square plus Ry square gives you what? Okay, resultant. Now what you asked me to find out? ACM, alpha, reaction of the hinge. I've given everything. I repeat the question again. Repeat the question again. See, the core part lies in applying torque equation about this point. About this point, moment of inertia is, what is the moment of inertia about that point? Moment of inertia about A is 2 by 3 MA square. You know to go chal me ki part ke. 2 by 3 MA square. So therefore, about A, this is 2 by 3 MA square. So therefore, about A, it is mg minus Ry is MACM by. Agreed? So I have applied a sigma Fi condition, sigma Fx condition, and torque equation. Right. Naneshwari, any doubt? If possible, message me.
Sir, can you repeat the part after alpha is equal to 3G by 4A?
Yes, exactly. Very good. See, please try to understand. This is pure rotation about the axis. Yes or no? About this axis, it is pure rotation. At that instant, the center of mass is having an acceleration R alpha. So clearly, ACM is equal to R alpha because it is a pure rotation, because fixed axis. So R you already know, A by root 2. Because diagonal is root 2A, half of that is A by root 2. That's all. Now I know ACMX, ACMY, because that makes an angle 45 degrees with the horizontal. The ACMX I know, ACMY I know, and thereby I have determined everything. Dhaneshwari, confirm.
Yes, sir.
Right. This is the simplest model, actually. Another model related to them, related to the same thing, but of tougher side. Again, this is a square plate, ABCD. Unlike the previous case, this is an equilibrium actually. Now in such a case, you are cutting at this point. This is again square plate, mass M, dimension A. Now tell me, is A fixed axis here? See here, A is not a fixed axis. So now tell me about which point it is preferred to apply the torque. Apply torque equation about center of mass because A is not a fixed axis. You apply this about the center of mass. By the way, that is the picture what you have. Any doubts? Till now, any doubts? Immediately after cutting, you will have a tension here at this point. Tension. So therefore, a torque equation, sigma torque about the center of mass implies the only force is tension force. About center of mass, what contributes torque? Tell me what contributes torque? Tension only. Tension into A by 2 is equal to ICM alpha. Can someone please help me in writing ICM? Yesterday only we have done. About CM, what is the moment of inertia? MA square by 12 plus MA square by 12, MA square by 6. Alpha. So wherever I have T, I can write this as MA alpha by 3. Let this be equation 1. Now I see only upward forces. There is no horizontal force. So you apply sigma Fi condition. Mg minus T is equal to MACM. Dakshesh, what are unknowns in this? What are unknowns in this? Bhavana Jata. అరే మాస్ నేను ఇచ్చాను రా అన్నీ నువ్వు ఏసీఎం టీ టీ కూడా ఇలా ఆల్ఫా రైట్ సో వాట్ ఆర్ అన్నోన్స్ హియర్ ఆల్ఫా ఈజ్ అన్ అన్నోన్ టీ ఈజ్ అన్ అన్నోన్ ఏసీఎం ఈజ్ అన్ అన్నోన్ దీస్ ఆర్ అన్నోన్ సో హౌ మెనీ ఈక్వేషన్స్ యూ రిక్వైర్ ఫర్ దిస్ 3 till now you have written 2 what could be the third equation obviously you require 3 equations you have written only 2 and there is no scope to write sigma fx. Now tell me how to write the third equation. Anyone in the class? Sorry, from your class or any students here? ఎలా రాస్తా అది ఫిక్స్డ్ యాక్సిస్ కదా రాసేది. About the center of mass, if you see, this is R alpha. Tell me. Tell me. Yes, you can tell that. How? I will explain. The point A will have 3 accelerations now. Actually, 2 acceleration. One is R alpha, the other is ACM. Yes or no? This is the point A. But don't forget, A is connected by means of a string. So therefore, along A, the acceleration must be 0. Because along the length of the string, acceleration of A is 0. Why? Yes, good. I feel proud of my students all the time for this reason. Length of the string is constant. మీరేం చెప్పాడో లేదా గర్ల్స్ ఎవరో చెప్పారు చెప్పావా గట్టిగా చెప్పాలి మీరు. రైట్, వీళ్ళు దగ్గర ఉన్నారు కదా మరి తొందరగా వినిపించేసింది. Acceleration along the length of the string is 0 because string is inextensible. So this is 45 degrees, you know. So therefore, ACM must be equal to R alpha. ACM is A by root 2 alpha. Equation 3. You have 3 unknowns, 3 equations. Okay, no issues. So now what I need to do is I will use equation 2 and equation 3. So that I'll get equation 2, equation 3 and equation 1 I will use, and I will add 1 and 2. So 1 and 2 gives mg is equal to MACM plus MA alpha by 3. M times ACM A alpha by root 2 plus A alpha by 3. Right. I think I am very clear on this, but please confirm if I am wrong anywhere. అరే ఏసీఎం ఇది ఎలా అవుతుంది? ఇందులో 1/√2 టర్మ్ ఉంది కదా, ఆర్ ఆల్ఫా కాస్ 45 కదా. ఎస్ ఆర్ నో? కాబట్టి అప్పుడు ఇది 2 అవుతుంది. So this will become 5/6 times MA alpha. So therefore, A alpha can be written as 6/5G. So therefore, tension is equal to M/3 times A alpha. 6/5G. This is nothing but 2/5 mg. Any doubts? Given I have given you everything. You know ACM also. ACM is A alpha by 2. Now what is A alpha? 6G/5. Now A alpha by 2 is 3Z/5. Please try to understand. I have given you ACM. I have given you tension. And I have given you alpha. All. Now please tell me, have you understood? Because I don't want to rush here. I want a confirmation from your side whether you understood all these steps or not. Jnaneshwari, first you tell me, have you understood all these steps?
Yes, sir.
Dakshesh?
Yes, sir.
Right. Chandanesh.
Yes, sir, understood.
Right, good. Bhavita వచ్చిందా క్లాస్ కి వాళ్ళ?
Yes, sir.
రైట్. నెక్స్ట్. ఎనీ డౌట్స్? రైట్. మీరు ఎక్కువ ఉన్నారని ఇక్కడికి వచ్చి యాక్చువల్గా వాళ్ళ దగ్గర క్లాస్ చెప్తానని చెప్పాను నేను. రైట్. వాళ్ళు 10, మీరు 10. ఇంకెవరన్నా యాబ్సెంట్ గర్ల్స్లో? గుడ్. అది మంది డెసిషన్ తీసుకోవటమే మంచిది. ఇంకో అమ్మాయి ఉండాలి కదా. చాలు. నీ పేరేంటి? తేజస్వి పక్కన అనలేదు. కొంచెం టైం పడుతుంది నాకు పేర్లు. 7 పేర్లే ఈ మధ్య నోటుకొచ్చినాయి. నెక్స్ట్. ఇప్పుడు హింజ్, స్ట్రింగ్ కదా. నెక్స్ట్ దిస్ ఈజ్ యువర్ this is your square plate this is again square plate, mass m, radius a. The only difference is what happens. Clearly in this case, initially the springs are under elongation, and obviously both, since force constants are the same, what I can say is that initially ke, each spring is mg by 2. Agreed? Right. Now you just have cut here. Immediately after cutting, see, one thing that you need to remember is the spring still exerts mg by 2. You have cut the right part, but the elongation in the left part is still the same. It won't recover immediately like string or hinge. That is the difference. Hinge lo laga, string lo laga, immediately it won't recover. Spring takes some time because the elongation is still the same. Now what happens? Not clearly, the force is mg. So therefore, the acceleration of the center of mass straight away in one step, Oranga, mg minus mg by 2. So ACM is g by 2. Even you can give acceleration of angular acceleration. Apply torque equation about the center of mass. Why I am applying torque equation about center of mass? Because this point is free. So this is nothing but mg by 2 times a by 2. What is the moment of inertia of this plate about this point? ma square by alpha. Therefore, alpha is 3 by 2 times G by A. Right. That's all. What else you want in this? And one more case is pending in this. 3 cases I taught you. 4th case, what is pending is, let me just see that I have that question or not. Let me just see this question. Suppose if I don't find a direct class today, I'll record some content. Today also, the moment when you are back to home, just go through this. A thin uniform bar AB of mass capital M and length 2L is held at an angle of 30 degrees to the horizontal by means of 2 vertical strings at each end. The string at the right end breaks. Find the tension in the left string immediately after the right string breaks. Okay, fine. I'll follow the same steps again. The moment it breaks here, there's the tension at A, mg 30 degrees. Right. In this case, I am assuming ACM alpha. Mg minus TA is equal to MACM. Equation 1. Any doubts? Next, torque equation. Torque, which point you need to apply torque now? Center of mass. Okay. So torque about the center of mass implies mg. This is a line of action. Oh, no, sorry. You're applying about the torque. Tension TA into, this is the line of action of the force. From the center, what is the perpendicular distance? You said 2L, actually. L root 3. అంతే కదా 2L cos 30, L root 3. TA times L root 3 is equal to torque, is equal to I alpha, ml square by 12 alpha. So TA is ml alpha by root 3. Again, root 2, 12 root 3. అంతేగా? Yes or no? Confirm? Right. Because it is not ml square, because the length is 2L here. So therefore, TA times L root 3 is m times 2L square. Because the length is not L. ml square by, you are applying torque about this point. So moment of inertia, about this point, moment of inertia. Stare about an axis passing through the center perpendicular to the length. ml square by 12. What else? నువ్వు ml square by అక్క ml square by science కి ఇది కాదు, యాక్సిస్ ఇంక్లైన్ అయితే ఎందుకు √3/2 రాయాలి? ఇంకా ఇగో ఇక్కడ రాసేగా మా ఇక్కడ చూడు, యాక్చువల్గా ఇది 2L cos 30 కావాలి. అప్పుడు ఇదేమవుతుంది? ఎందుకు L/2? ఈ మొత్తం అంతా 2L కదా, అప్పుడు 2L cos 30 కదా. ఓకే, ఓకే, గట్ ద పాయింట్. L√3/2. గుడ్, రైట్. అమ్మ ఇప్పుడు టీఏని ఏమని రాస్తారో నాకు చెప్పండి. పైన 4, కింద 3, 2ml/3√3. ఓకేనా ఇది? ఇప్పటికి ఇది 2-3 కరెక్షన్స్ తర్వాత వచ్చింది. జస్ట్ కన్ఫర్మ్ వెదర్ ఇట్ ఈస్ ఓకే ఆర్ నాట్. ఓకే, ఓకే ఆర్ నాట్? ఒకసారి ఆగుతాను మళ్ళీ. జ్ఞానేశ్వరి, ఇస్ దిస్ ఓకే?
Yes, sir.
దక్షేష్,
Yes, sir.
ఆల్ఫా మిస్సింగ్. You said okay for this. Alpha missing. Right. So again, what are unknowns? Alpha unknown, ACM unknown, tension unknown. You require one more equation. You got only 2 equations. You require one more. How to identify that? Now point A. Now point A will have L alpha acceleration, ACM acceleration. Agreed? Try to understand. Can you please help me in this angle? Are bhaiya, if this is 30, this is also 30. So along the length of the string, acceleration is 0 because string is inextensible. Kabatti ACM is L alpha cos 30. Okay, ACM is √3L alpha by 2. So you have the third equation. Now you solve these 3 equations, you will get the required answer, right? So may I leave this here because we need to do lot of questions today. So solving 1, 2, 3, we will get all the 3. I'm just leaving. Any doubts you can ask me. Next question. In the same, it comes under the same school, small change. This is the length of the rod. This is held at rest like this. It is held horizontally 30 degrees, 60 degrees. Let this be end P. And you just cut the string here. Remember, immediately after cutting, let the tension in the string be TV. Weight is mg. Now the center of mass will have 2 components again. Why? It has a force in force has some x component as well as y component. So therefore, ax, ay, ax. TB cos 60 is equal to MAX, equation 1. MG minus TB sin 60 is equal to MAY, equation 2. MAY, equation 2. Any doubts? Next. Yeah. Now, what about the torque equation? Torque equation is to be applied about the center of mass. About the center of mass, torque equation is what you want. It will have two components, TB cos 60, TB sin 60. But TB cos 60 will not contribute any torque. Why? Intercepting center of mass. MG will not contribute any torque because it is also intercepting. So therefore, this is TB sin 60 times L by 2. That is the torque. And that is equal to I alpha. So TB root 3L by 4 is, can you please help me in writing? I about center of mass actually. ML square by 12 alpha, right? So finally TB is ML alpha by 3 root 3. Right. That's the deal. That is the deal. Right. Any doubt till this point? Pakka. Right. I got, how many unknowns were there? Just let me write. Tension at B, AX, AY, A alpha. You have 4 unknowns. Unknowns are 4. So we require one more. What is that equation? Again, the same concept. At B, this is the string, which makes an angle 60 degrees. You have AX here. You have AY here. You have L by 2 alpha up. That is the direction of the string. So along the length of the string, acceleration must be 0. Along the length of the string, acceleration must be 0. If this is a 60, this is 30. So AY cos 30 is equal to AX cos 60 plus L alpha by 2 cos 30. Why? Because this is 30 degrees. Okay. So you have the equation root 3AY is AX plus L alpha root 3 by 2, equation 4. Now you have 4 equations. You have 4 unknowns. By solving 1, 2, 3, 4, you will get the required answer. Now please everyone go through this question and tell me, do you have any doubt in handling this? Every student in this class, try to please answer. All these are the applications of torque equations. Right. Jnaneswari, any doubt?
No, sir.
Right. Dakshesh?
No, sir.
Right. Now we will move on to the other models. One after the other we will do. Let me target how many questions? 1. Already we have done this. No issues. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I can finish these 10, maximum part of torque equations are done. I'll handle one after the other. I'll handle one after the other. Right. I'll just handle one after the other. Meanwhile, let me adjust the space properly. Right. It's an excellent question. Please go through this. Read the question properly. You have uniform cylinder of radius r. Now see the direction of the spin. When this is spinning like this. Okay. Now on the, what is the cylinder? Wall will exert a frictional force F1. Floor will exert a frictional force F2. Wall will exert a normal reaction N1. Floor will exert normal reaction N2. That's the picture. Right. Now in this part, what is happening? See, first, I will see only few terms. My approach is the same. Sigma fx is equal to 0, which implies sigma fx 0 means, tell me, F2 is nothing but N1. Sigma Fi 0, which implies N2 plus F1 is mg. Let this be equation 1. And let this be equation 2. And slipping is happening. So wherever friction is there, it is a kinetic friction only. And from this I can write N2 plus F1. F1 is mu N1 is equal to mg. Any doubt? But N2 plus mu. What is N1? F2. అంతేగా ఇక్కడ N1 అంటే F2 కదా. F2 is nothing but mu అంతే కదా, mu N2 is equal to mg. See, remember, mu N2 is N1. That's what I've written here, sigma fx 0. Mu N2 is N1. In the place of F1, I have written mu N1. That's the difference. That's all. So finally, I got N2 as mg by 1 plus mu square. What is N1 then? Mu N2. ఇక్కడ ఇచ్చావుగా mu N2 is N1. So mu mg by 1 plus mu square. అది ఎవరికి కావాలప్ప నార్మల్ రియాక్షన్స్. అడిగిన క్వశ్చన్ ఏంటి? హౌ మెనీ టర్న్స్ విల్ ద సిలిండర్ అకంప్లిష్ బిఫోర్ ఇట్ స్టాప్స్? పాపం ఇప్పుడు సిలిండర్ గారిని చూడండి. For the cylinder, the torques, see, this is that sense of rotation. Whereas all the torques, frictional torques, are opposing the motion. All are opposing the motion. Yes or no? Why? F1 is clockwise. F2 is nature of rotation is anti-clockwise. So therefore, minus F1R minus F2R is I alpha. Why I did not consider mg, n2, n1 here? They are passing through the centers. F1 mu n1 R minus mu n2 R is ICM alpha. So alpha is minus will come because it is a retardation. Mu n1 means mu square mg by 1 plus mu square plus mu n2 mu mg by 1 plus mu square divided by IR is also there, of course. Cylinder mr square by 2. So finally, alpha is నాకేమన్నా చెప్తారా mu square plus mu mg by 1 plus mu square r cancel 2 mg by mr. M also cancel. 5 అంతేగా ఆల్ఫా ఇస్ ఎందుకులే పెద్ద ఉపయోగం ఉంటే తీసేవాడిని పాటికి 2g by r ఆల్ఫా. ఇంకేమైనా మీకు ఏం కావాలి? డిస్ప్లేస్మెంట్ బిఫోర్ ఇట్ కమ్స్ టు రెస్ట్. నాకు ఇది నన్ను ఇదే దీనిలో అడుగుంటే ఐ విల్ యూజ్ v square minus u square is equal to 2as. Finally rest. Initially omega naught square 2 minus mu square plus mu by 1 plus mu square 2g by r into theta. Now what I got is theta implies theta is equal to 1 plus mu square omega naught square by 4 times mu square plus mu times g. This is the angular displacement. That's not the answer. If theta is the angular displacement, divided by 2 pi gives number of rotations, because 1 revolution per second is 2 pi radians per second. So you want in revolution per second, divide angle by 2 pi. Therefore, number of revolutions done is equal to 1 plus mu square times omega naught square by divided by 2 pi kada ante 8 pi g times mu square plus అదో కాదో చూసుకుందాం. రైట్. ఆర్ టర్మ్ ఎక్కడన్నా మిస్ అయింది? ఆరు ఇక్కడ ఆర్ మిస్ అయింది. ఇక్కడ రాసా, ఇక్కడ ఆరు పైన వస్తుంది. ఆరు పైన వస్తుందా? రైట్. ఎనీ డౌట్స్? బాయ్స్ అండ్ గర్ల్స్, సేమ్ ఆన్సర్ ఇస్ వాట్ వీ గాట్. 1 plus mu square. అరే ఆడు mu కామన్ తీసేయాలి, అది వేరే విషయం. వీ గాట్ ఎవ్రీథింగ్ ద సేమ్. No, we don't require this. Right. Boys and girls, very good and repeated model. You will get this question repeatedly in any of the CAT exams. If you miss this time, for example. Gyaneshwari, any doubts?
No, sir.
Dakshesh?
No, sir.
Right. Next. Are we clear? ఇది షువర్గా చూసుకుందాం. రైట్, ఇది చూడండి ఒకసారి. Read the question carefully. Everyone. A uniform solid cylinder A of mass m1 can freely rotate about a horizontal axis fixed to the mount of mass m2. Have you seen both the masses? Yes, right. A constant horizontal force F is applied to the end K of a light thread tightly wound on the cylinder. The friction between the mount and the supporting horizontal plane is assumed to be absent. Find the acceleration of the point K. Right. Find the acceleration of the point K. My point is very clear. You are applying, this is something, some hinge-like structure, and you are applying some force F. That's all. This is what I have understood. This hinge will have an acceleration A1, same acceleration as that of the lower part. And there is a reaction, no? Hinge reaction. Let that reaction be R hinge. Okay, on the other arrangement, RH, and this point will have the same acceleration. So therefore, that will also have an acceleration A1. Now, please confirm, have you understood the free body diagram of both the entities? Pavana, clear? అవును, ఇప్పుడు ఈ హింజ్ దీనికి ఫిక్స్డ్ కదా. ఇది RH అయితే యాక్షన్, ఇది రియాక్షన్ RH. స్మూత్ అంటున్నాడు కాబట్టి వదిలేసేయండి, ఇంక కింద ఇంకేం ఫ్రిక్షన్ గిస్టనే ఉండదు. Now please try to understand equations properly. Please try to understand the equations properly. Right. Now F minus RH is M1A1. RH is M2A2. Now I'm applying about this, the torque equation. F into R is I alpha. F into R is I, it is a solid cylinder. M1 R square by 2 alpha. So therefore, F is M1 by 2 R alpha. From these two, I can write A1 as F by M1 plus M2. Sir, what is the question and what you are doing? I'll explain. They want the acceleration of this point. They want the acceleration of this point. Remember, the acceleration of the lower point comprises of two things. With respect to this, R alpha. So this is point K, for example. Acceleration of K with respect to the hinge is R alpha, right side. Acceleration of K minus acceleration of hinge is R alpha. Acceleration of K is acceleration of hinge plus R alpha. Acceleration of hinge is nothing but A1. A1 plus R alpha. This is nothing but 2F by M1. What is A1 by the way here? What is A1? A1 is F by M1 plus M2 times 2F by M1. Acceleration of K is M F1 FM1. Array just there outside. That's all. You'll get this one. Trust me. Space లేదు కదా. Okay. Any doubt on this? Emma, do you have any doubt on this? Naneshwari, any doubts?
Sir,
Which step? Any doubt in any of these steps?
no, sir.
Right. Right. Are we clear on this? This is a very standard model. Right. A similar model. It's also a similar model. But today, I think you have understood my approach. I am totally applying on torque equations. Right. A disk of mass M and radius R is pivoted smoothly with a block of mass capital M. A force F1 acts on M. Okay. And another point. The linear acceleration of the bodies, angular acceleration of the disk. Intakanna easy question. What is if I take the entire thing as one single system? What are the forces acting? One force is F1, the other force is F2. Acceleration is F1 minus F2 by capital M plus small m. Any doubts? Next, that is acceleration. F1 minus F2 by capital M plus small m. Next. ఇంకో పాయింట్ ఏంటంటే about this point, about the hinge, F1. So R alpha angular acceleration of the disk is what here? About ఇది డిస్క్ కదా, రైట్. F1R is equal to MR square by, అరే ఇది స్మాల్ ఆర్ రా, మీరేం మళ్ళీ అదే క్వశ్చన్ అడిగా మీరు. ఇది స్మాల్ ఆర్. F1 small r is MR square by 2. So there MR square by 2 alpha. Alpha is 2F1 by MR. అయిపోయింది. Most simple question. Actually, when compared to this is a simple question. Next. Yeah. Why don't you try this? Answers are also available for you there. We assume that the tension is a T1 here and the tension is a T2 here. Tension is a T2 here and tension is T1 here. And this is A1 acceleration and this is A2 acceleration. At this point and at this point, for the length of the string to remain a constant, A1 is a capital R alpha, A2 is a small r alpha. Any doubts? Right. And this is your radius of gyration K means moment of inertia is Mass of the pulley is also M. Mk square alpha. Hold on. This is the first equation. For the first block, what is happening? Mg T1 A1. Mg minus T1 is equal to M A1. A2. So how many unknowns are there? T1, T2, A1, A2. I have given you 4 equations accordingly. T1, T2, A1, A2, alpha. I have given you 5 equations actually. We given you 5 equations. Now by solving 3, 4, 5. By solving, we will get these accelerations. Do you wish me to solve or is it okay? Why I am doing this? Because to maximize the number of questions per day. Right. Jnaneshwari, do you have any doubt?
Sir,
Right. Dakshesh.
No, sir.
Moment of inertia and all that we will do later. 1, 2, 2, 3, 4, 5. 5. 5 is my target now. If I can complete this, I am on safe side. Right. Safe side in the sense. Right. A pulley is in the shape of a uniform disk of radius r. Its mass is capital M. It can rotate freely about its fixed horizontal axle. A light thread is tightly wound on it. Free end of the thread is connected to a block of mass M. System is released by the acceleration of the block and angular acceleration of the pulley. Right? No issues. If you see it from the side view, if you see the same arrangement from the side view, that arrangement looks like this. Remember, let the acceleration of the block be A and the block experience weight mg, tension T, alpha. By this point will have an acceleration of r alpha. For the length of the string to remain constant, r alpha is equal to A. That is the first point. Free body diagram of this gives you mg minus T is equal to ma. Equation. Don't forget A, alpha, T. These are the unknowns in this question. 3 equations. Then what is the third equation? I have given only 3 equations. What is the third equation? Torque about the hinge. Torque about hinge. So that gives you T into R is, it is like a disk. Capital MR square by 2 times alpha. T is M by 2 R alpha, which is nothing but M by 2 A. Equation 3. Simple. You got the point. equation 2 plus equation 3 implies mg is array tension gets cancelled. Correct. That's all. అరే ఏ వస్తే ఆల్ఫా వచ్చేసినట్టే, ఆల్ఫా వస్తే టీ వచ్చేసినట్టే. That's all. Any doubt? So elementary fundamental question. Next, I don't see any difference between that and this, but only thing is the way of applying equations slightly become different. Okay. First, Gnaneshwari, do you have any doubt in this?
No, sir.
Pakka.
Yes, sir.
Right. And Dakshesh?
Yes, sir.
Right. Thank you. Right. Can you try this? Remember, we have only 20 minutes. Combined rotation and translation of a body. Light thread is wound tightly around a disc of mass capital element radius r. Free end of the thread is fixed to the ceiling of a room and the disc is released. Find the acceleration of the disc. Mg minus T is equal to MACM. Right. Next, torque equation. ఇలాంటి అన్నింటిలోనూ మనం టార్క్ ఏ పాయింట్ తీసుకుంటాము? సెంటర్ ఆఫ్ మాస్. రైట్. అదే ఇప్పుడు నాకేమనిపిస్తుంది అంటే, ఆనెస్ట్గా చెప్పండి, ఇవాళ కొత్త పాయింట్ ఒక్కటనే చెప్పాను నేను. అదే ఇలా మనం ఫిజిక్స్ చూడగలిగితే పేపర్ ఆడుకునే వాళ్ళు. క్వశ్చన్ పేపర్ జస్ట్ గేమ్ అవుతుంది మీకు. మీరు అలా చూడరు ఎగ్జామ్కి వెళ్ళేటప్పుడు. అదేదో పెద్ద ఓషన్, ఇదేదో ఓషన్ అన్నట్టుగా చూస్తారు. అందుకే మనకు మార్కులు రావు. మార్క్స్ కన్వర్ట్ చేయటం. అసైన్మెంట్ స్టేటస్ ఏంటి? స్టార్ట్ చేశారా? రైట్. రైట్. టెన్షన్ ఇంటూ రేడియస్ is equal to tension into radius is equal to mr square by 2 alpha. Tension is an unknown, alpha is an unknown, ACM is an unknown. We require one more equation. What is that equation? For this disk, only due to rotation, you will have R alpha acceleration. Only due to translation, you will have ACM acceleration. Don't forget that is the same end of the string. And the above point is fixed. So therefore, ACM is equal to R alpha, equation 3. Clear? Boys and girls, any doubts? Right. So therefore, from this, what can we conclude? Yeah, just solve this. You will have this relation, and using this 1 and 2 and 3 implies mg is equal to MACM plus MACM by 2. 3 by 2 MACM. Therefore, ACM is 2 by 3G. Two by 3G. Any doubts? Clear? Right. Now we will have this question right now. Actually, most of these models are Irido models. Most of these models are. This is an Irido question. This is also an Irido question. Right. Very good, famous models. But I see it in simple sense, that's all. అరే నువ్వు ఎన్ని సిలిండర్ ఎన్ని డ్రమ్ములు ఇచ్చినా నాకు కనిపించేది ఒక. Now you call this A. You said that you call this as A. The side view A. This is what I'm saying here. B. Are they same uniform cylinder? Mass A, radius R, is suspended symmetrically vapor strings. B is another string. ఇక్కడ the string holding B is wrapped on A in opposite sense. వాడు ఏం చెప్పినా మనం చేసేది మనం చేయటమే కదా డయాగ్రామ్. Wrapped like that. ఓకేనా? Wrapped opposite sense. మాస్ ఏమి ఇవ్వలేదే, ఐడెంటికల్ సిలిండర్. They said identical cylinder. Right. Good. Mg alpha B T2 T2 T1. ఇది ఎంత ఛాలెంజింగ్ అంటే మనకి జాగ్రత్తగా చేయాలి క్వశ్చన్. ఆల్ఫా ఏ. ఫస్ట్ డయాగ్రామ్ అర్థమైందా లేదా చెప్పండి. Just convey me that whether you understood the diagram or not. That is the first target for you. That's the first target. Okay, right. Control Z. Just space కోసం దీన్ని ఇక్కడ తీసుకొస్తున్నా. Right. Now you study only A. See, only A. This point will have R alpha A plus acceleration of A, center of mass of A అని. T1. T2. Right? That is a clear picture. ఇక్కడ ఏం చేస్తారు మీరు లోవర్ బ్లాక్ ఫ్రీ బాడీ డయాగ్రామ్ రాస్తున్నా. లోవర్ బ్లాక్ వచ్చేసి T2 MG ఈ పాయింట్కి R ఆల్ఫా B AP. ఇక్కడ జరగాల్సిన పాయింట్ ఏంటంటే ఈ పాయింట్ సేమ్ యాక్సలరేషన్ ఉండాలి. అలా ఉండాలి అంటే AB మైనస్ R ఆల్ఫా B మస్ట్ బి సేమ్ యాజ్ R alpha A plus AA. This is the constraint relation. This is the constraint relation. Now, please confirm, have you understood the second equation? Yes or no? Next. The next part. See, for this torque equation, T2 minus T1R is mr square by 2 times alpha A, equation 3. For this torque equation, T2 times R is equal to mr square by 2 alpha B, and mg minus T2 is MAB, equation 4, equation 5. What are unknowns? T1 is an unknown, T2 is an unknown, alpha A is an unknown, alpha B is an unknown, AA is an unknown, AB is an unknown. So you require actually 6 equations. You require actually 6 equations. T1 unknown, T2 unknown, alpha A unknown, alpha B unknown, AA unknown, AB unknown. But now, where do I get the 5th equation? Torque equation, translational equation given. Torque equation, translational equation given. Relation between these two given. Where do I get the 6th equation? Where do I get the 6th equation? Nyaneswari, any help from your side? Where do I get the 6th equation? Anyone in the class? Anika చెప్తావా? ఎక్కడ ఈజ్ ఈక్వల్ టు ఆర్ ఆల్ఫా? నువ్వు ఎంసెట్ చదివే ఈ ఫార్ములాల అప్రోచ్లో చదివితే అనిక రాదు, ఫిజిక్స్ రాదు. Still, we need to make one more equation. Now tell me where you allow me to apply those to get that particular equation. Era Varun ga strike atla. We require one more equation, and we still have the scope to write one more equation. But you should identify that what is the point. Everyone worked here, but no one worked. At this point, you will have R alpha, you will have EE. So therefore, AA is R alpha. Remember, this is your 6th equation. Why? Because when I am writing T1 means both together T1 by 2, T1 by 2. లేకపోతే కొంచెం కన్ఫ్యూజన్ ఇబ్బంది అవుతుంది. అందుకని ఫర్ కన్వీనియన్స్ ఐ హావ్ రిటన్ T1 by 2, T1 by 2. నో ఇష్యూస్, నథింగ్ రాంగ్. అరే నెట్ అప్వర్డ్ ఫోర్స్ ఇస్ T1. ఒకవేళ మీరు T1 రాసి ఉంటే 2T1 అయ్యేది. మేక్స్ నో డిఫరెన్స్. రైట్. So you have equations R alpha A, by the way. That's all. Now you have 6 equations altogether. Solve these 6 equations. They are not bit difficult. They are easy actually. See, if you add, if you see, you can eliminate T2 from these 2 equations. You can get T2 from here. So here, finally you substitute this particular thing. That's all. AA is equal to R alpha A. I have concluded here itself. So unknowns T1, T2, alpha A, alpha B, AA, AB, 6 equations are available. You better solve this, you'll get the answer. Gnaneswari, any doubt?
No, sir.
Have you followed the complete 6 equations?
Yes, sir.
Right. Now let us try to understand what is happening here. Cylindrical rod of mass M and length L and radius R has a 2 cords wound around it, whose ends are attached. Okay, the rod is held horizontally with the 2 cords vertical, then the rod is released, the cords are here, find the tension. నేను ఏది చెప్పినా నాకు కనిపించేది ఏంట్రా అంటే ఒక సింగిల్ సిలిండర్. ఇన్ ద ప్లేస్ ఆఫ్ T, I will write 2T and I will write mg. In what way this question is different from this one? Both are same. Therefore, everything is the same. So mg minus 2T is MACM. Similarly, 2T into R is equal to mr square by 2 alpha. Similarly, at this point, up is R alpha. The downward direction acceleration is ACM. For the length of the string to remain constant, ACM is equal to R alpha. You have equation 1, you have equation 2, and you have equation 3. Solve those 3 equations, you will get the answer. Very simple. Any doubt? Pakka? Right. And this is the last question. I will take it right now. Last question. Here, I am not doing any different questions today. Just repeating questions. The last question. Okay, trust me. You can see the arrangement here. A pulley B, mass of this pulley. Which one? Pulley means this one. B possess mass M. Also known the moment of inertia I of the pulley relative to the axis. About this axis, I, moment of inertia. Internal R, external 2R. The mass of the thread, find the acceleration of the weight A after the system is set free. The mass of this one is smaller. If I see this in this way, right? Clearly, you have 2T1 T2 ACM. A1 రాద్దాం లేదా AA రాద్దాం అదర్వైజ్ AA బ్లాక్ కి ఈ పాయింట్కి ఏమేమి యాక్సలరేషన్స్ ఉంటాయి. దిస్ వన్ విల్ హ్యావ్ అన్ యాక్సలరేషన్ ఆఫ్ the center will have an acceleration of AB. So this point will have an acceleration of AB plus 2r alpha. See, if this length of the string constant, for this to happen, AB plus 2r alpha is the acceleration of this point. That should match with the AA. Equation 1. Next, one more important point. Here you can write mg minus T2 is MAA. Equation 2. For this, mg minus mg plus T2 minus 2T1 is MAB. What are unknowns? T1 is an unknown, T2 is an unknown, alpha is an unknown, AA is an unknown, AB is an unknown. 1, 2, 3, 4, 5 equations are required. I could manage only 3 by this time. What else? Torque equation here. Torque equation. 2T1 times R plus T2 times 2R is I alpha. What is the fifth equation? చెప్పమ్మా అమ్మా ఎట్లా AA is equal to R alpha? ఇక్కడ చెప్పాలి. ఇది ఫిక్స్డ్ కదా. ఈ పాయింట్కి వచ్చేసేటప్పటికి యాక్సలరేషన్ ఏమవుతుంది? ఆర్ ఆల్ఫా ఏబి. ఏబి ఈజ్ ఈక్వల్ టు ఆర్ ఆల్ఫా, ఏఏ కాదు. రైట్. ఈక్వేషన్ 5. అరే వాట్ ఈస్ ద డిఫరెన్స్ బిట్వీన్ దిస్ వన్ అండ్ దిస్ వన్? అది 6 ఈక్వేషన్స్, ఇది 5 ఈక్వేషన్స్ అంతే. ఇది రొటేషన్ లేదు కాబట్టి 5 ఈక్వేషన్స్. Now are we clear now? You need to find T1, T2, alpha, AA, AB. Yes or no? So how many equations I have given you totally? 5. So that's all. Just solve this. Now how many problems are left for us overall week-wise? 1, 2, 3, 4. Some questions were there. ఇంకా కొన్ని తీసేయచ్చు ఇందులోంచి. ఇవి కూడా తీసేయచ్చు కదా, చెప్పేసాం. యా అయిపోయితే వెళ్ళిపోండి అమ్మా క్లాస్కి. ఇది ఒకటి చెప్పాలి. Some 6, 7 questions here. Some 6, 7 questions here. Basics actually. This I will cover tomorrow. Balance I will cover tomorrow. But some Pathfinder based questions, నేను సెల్ఫ్ వీడియో తీసేసుకొని పెట్టేస్తాను. Pathfinder questions ఇవాళ కొంత, రేపు కొంత తీసుకొని సెల్ఫ్ వీడియో చేసి పెట్టేస్తాను. ఓకేనా? రైట్.